Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Chapang Mapotsani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12, in today's lesson, we are focusing on paper 2 revision, and this is going to be our part 1 of the paper 2 revision, and we are going to focus on Euclidean geometry. Now, by the end of this lesson, grade 12, you must be able to identify and know the structure of paper 2. And we are focusing on the following topic. We are focusing on Euclidean geometry and measurement. Now, this is our structure for paper 2. And you must be familiar with this structure. Remember, this is the structure we're going to use for a full-blown exam where we are having our prelim and the final examination. But then for June exam, we're saying analytical geometry is going to form part, trigonometry is going to form part, and Euclidean geometry and measurement is going to form part. So it is only statistics that is not going to feature in our June examination. So as we can see, all of the three main topics will be forming part of our examination. So today's lesson, it focuses on Euclidean geometry and measurement, and that topic, it is weighing 27% of our paper. That is 40 marks in our question paper, and it is mostly found in question 8, 9, and 10. So it doesn't have to really be question 8, 9, and 10, but it has those three questions, and it is usually the last questions of the paper. So depending on the structure, there might be slight different changes there or differences there. And you must also note that the theorems and or the trigonometry proofs have maximum marks allocated at 12 marks. So any proof that you are going to make, we are saying to you, all of the proofs combined in paper 2, they must have maximum marks of 12. Now, what can we expect with regard to Euclidean geometry in our examination? We are saying Euclidean geometry has 5 types of questions. And the first question, it is a basic question where it requires you to apply the Euclidean geometry theorems to find the sizes of angles or lengths. So this one is the basic question that operates within working with the theorems and applying the theorems to our diagram that is given. Number 2, we are going to also have a more complex question that focuses on proofs where we'll be required to prove tangents, diameters, cyclic quadrilaterals, etc. So this one focuses on mostly on proofs. So here we're working with proofs for the second type of a question. The third question is going to be a question on proving the theorems. So this one, it is the one that we are going to be given a diagram. We are supposed to prove a particular theorem. And very important here, you must always note that you must always have the construction when we are dealing with the proving of theorem. The difference between number 2 and number 3 is the following. Number 2, we are going to be given a sketch whereby you are using that sketch. Maybe you'll be even given the variables, maybe x, y, that you're going to utilize to be able to prove a line as a diameter, to prove that we are having a cyclic quadrilateral, etc. And when we're looking at question 3, it is just a question on proving an actual theorem. Number 4, the fourth type of a question, it is where we are dealing with the application of similarity and proportionality. But remember that this is the topic we have introduced in grade 12. So you must also understand that the topic is going to feature in our examination. And the last question, it is going to be a question that assesses all concepts relating to Euclidean geometry. That is to say, this question will contain a basic application of Euclidean geometry. It will contain the more complex question whereby we are dealing with the proving of tangents, the proving of diameters, and the proving of cyclic quadrilaterals, etc. And also this question will contain the application of similarity and theorem. So the last question deals with all those type of questions that we had there. Right. Now let us look at what proofs we can expect in our examinations. So these are the examinable proofs for our examinations, and we must know that we have 5 grade 11 proofs that we must know for the examination purposes. Number 1, we must prove the theorem that states a line from the center bisect the chord or perpendicular to the chord. Number two, we are going to be required to prove the line from the center to the midpoint of the chord, which is the converse of this theorem of theorem one, which is line from the center perpendicular to chord. Number three, you will be required to also know the proof on the angle at the center. It is twice the angle at the circumference. Number four, we must know that opposite angles of a cyclic quad are supplementary. So you must be able to prove that opposite angles of a cyclic quad are supplementary. Number five, we must be able to prove a tan chord theorem. So those are the 5 grade 11 proofs that are going to feature or that must be known for the exam purposes. Now, and also we have the 2 grade 12 proofs that must be known for exam. So in total, we have 7 proofs that we must know and we must prepare for examination. 5 of those are from grade 11 and the 2 are from grade 12. The 2 are from grade 12 is the proportionality theorem, where we are going to prove that a line drawn parallel to one side of a triangle divides the other 2 sides proportionally. So we must be able to prove the proportionality theorem. Number 2, we must be able to also prove a similarity theorem. When you are proving the similarity theorem, we are saying if the 2 triangles are equiangular, then their corresponding sides are in proportion. And you must remember what we mean by saying they are equiangular. We are saying their angles are equal. So the angles of triangle A are equal to the angles of triangle B. So the similarity theorem, remember, it operates on the reason angle. So we're proving that all the 3 angles in both triangles are equal. Now, let us look at how to approach the Euclidean geometry questions. How do you approach this one? We must always undergo the process of pre-question analysis. What does the pre-question analysis help us to do? It just helps us to make connections with the angle in the sketch without responding to those questions that we are having in our on our questions. So when we are dealing with the pre-question analysis, the first thing that we're supposed to do is to read the statement carefully. We are going to analyze the keywords such as the center, cyclic quad, diameter, angles, sides equal. So in this case, we are saying to you, do not make assumptions that a certain point is the center of the circle unless you are told so. Do not make an assumption that a certain line is a tangent. Do not make an assumption that we are having a cyclic quad. But remember, with the cyclic quad, as long as I have 4 points that are lying on the circumference, that by definition, it is going to give us a cyclic quad. So 4 points lying on the circumference that are connected together, they are going to give us a cyclic quadrilateral. Number 2, fill in the information that you can identify from the statement on your diagram. So we are going to say, read the statement and populate your diagram with the important information that is found on the statement. Number 3, then using other information on the diagram, fill in other information on angles or sides. So what I'm saying here, after you have filled in information from the statement, go through your diagram, see what connections can you make with other angles to say which angles are alternating, which angles are equal, which angles are corresponding, and all of those things. So you must be able to do what? To just look at the relationship between the angles and see which angles are equal, which angles are related in what sense, or which theorems give us a relationship to which angle. So it's very much important we can do that. Remember, we are still doing the pre-question analysis. We are not yet tackling or we are not yet reading the question. So we are just looking at the statement, we are looking at the diagram, we are forming those relationships. Number 4, we have to make use of theorems to make calculations to indicate any relationship between the angles or sides. That's what we are doing here. So we are saying apply the theorems, make calculations, indicate any relationship between the angles or sides without the question pointing it out to say calculate this, calculate that. Right. Now, when we are dealing with a pre-question analysis, it is very useful to actually implement this abbreviation called Dr. CPT, Dr. Cape Town, can say. So it's Dr. CPT. How do we now work with this abbreviation of Dr. CPT? Number one, is there a diameter? That is for the first D, is our D there. Are we saying we are just checking our X cycle? We are looking at our statement. Do we have any diameter? Number two, do we have any radius or radii that create isosceles triangle? Remember, radius are two radiuses from the center. We are checking, are those radiuses creating an isosceles triangle or not? So are we having any radius? Are we having any diameter? So that is G and R. Number three, are there any cyclic quadrilaterals? With regards to the cyclic quadrilaterals, we are saying to you, look for 4 points on the circumference that are connected together. Do we have those 4 points? Now the question point out to us to say, we do have a cyclic quad to say A, B, C, D, it is a cyclic quad. So we are looking at those things, 4 points on a circumference, or is there a question pointing it out that we have a cyclic quad? Number four, are there any parallel lines? Do we have any lines that are parallel? Is the question, was the statement pointing it out that we have parallel lines, or can we see from our diagram that we have the parallel lines? Remember, with regards to parallel lines, I can just have those markings there or those indications that will tell me that these two lines are parallel. We must be able to see that these two lines are parallel without the statement having to point it out. So are we having any parallel lines? Number five, are there any tangents? Is a question pointing out or the statement pointing it out that we are having a tangent? Remember, with a tangent, we can't make assumptions. We must be told from the statement that line AB, for example, it is our tangent to the circle. Then we are going to apply the theorems under tangents. So as you can see, this abbreviation is going to assist us into applying our pre-question analysis. That is going to help us to analyze our question and be able to know how to approach that particular activity. Right, with that in mind, the 12th, we have a question 8. So this is question 8, and we have from 8.1.1 to 8.1.3. And for this question, grade 12, we are going to give you only 5 minutes to complete this activity. And your 5 minutes starts now. Welcome back, grade 12. Now, let us now focus on question 8.1. And for this question, I would like us to employ our pre-analysis strategy, which is Dr. CPT. Dr. CPT, we are saying we're going to start with the D nicely there. Are there any diameters? But before we apply that, let's start with our statement. In the diagram, O is the center of the circle, okay? They told me that O is the center of the circle. M and R is a cyclic quadrilateral. So I have a cyclic quadrilateral. So O is the center. And when you're analyzing a question also, be sure to be able to underline the key words or the key parts of the question. Then M and R, it is a cyclic quadrilateral. SN is the diameter. So those are the keywords. A joint MS and the radius OR are drawn. So OR is a radius. And M2, it is given as 64 degrees. So those are the information that we are having from our statement. Let us now go and apply our pre-question analysis on our diagram. So what we have then, we are told that Sn is a diameter. If Sn is a diameter, I'm expecting what? The angles in the semicircle. We can see that on that diameter, I can form a nice triangle there. I'm expecting M1 plus M2 to give us 90, because we can say that angles subtended by a diameter are going to give us a right angle triangle or a right angle, and that is the 90 degrees. What else do we know? We are told that this was a diameter, so we have the 90. Can we still apply anything about that diameter? For now, no. Let's move on. And we are going to proceed and say, do we have any radiuses? We are told that OR is the radius, and we can see that if Sn it's a diameter. That means, and O is the center. That means SO is a radius, and ON is also a radius. So SO, ON, and OR are all equal. Those are radius. So they are all equal. Those that are equal. Then what else we see now? Let's proceed. Do we have any cyclic quarks? Remember, the statement has already stated, pointed it out for us that MnPr, it is a cyclic quark. So MnPr, it is a cyclic quark. If that MnPr is our cyclic quark, we know that we are going to apply all the properties of a cyclic quadrilateral. We are going to apply properties like opposite angles of a cyclic quad are supplementary. We are going to look at the exterior angle of a cyclic quad, which is equal to the opposite interior angle. So I can see there is no line extended out of that cyclic quad. This one is not extended because the extended line, it must be a continuation of a line that forms that cyclic quad. I don't have any continuation of a line, so I don't see any external angle of a or exterior angle of a cyclic quad. So I can only depend on the opposite angles being supplementary. So those are the points that are going to work with us for cyclic quad. Are there any parallel lines? No. The statement does not point out any parallel lines. I do not see any diagram markings that can tell me I have a parallel line. So the parallel lines are out. So corresponding angles, alternate angles, and co-interior angles are out. I cannot utilize those. Then are there any tangent to the circle? We are not told anything about a tangent. And you can see from the diagram, there is no line that is a tangent here. But remember, we're supposed to be told. So no tangents are shown also on the diagram. Now, let us now go to our questions. I think we are now ready to deal with our questions. Or before we do that, we can have angle subtended or angle at the center twice the angle at the circumference. If we analyze the issue of that center there. So that is another one that was supposed to be part of our pre-question analysis. But let's move on. Determines given reasons the signs of P. Where is P found? P, it is found, if we remember well, it was found in our cyclic quad. So P and M2 are the opposite angles of a cyclic quad. So we are saying to us, P, we can say M2 plus angle P is equal to 180. And what is the reason? These are the opposite angles of a cyclic quad are supplementary. They add up to 180. Then how do we get that P there? Then M2, we already know it was 64 plus P, it's equals to 180. Then I can just transpose the 64 to the other side. Then angle P is going to be 180 minus 64 as we are having right there. Then our angle P, it will become 116 degrees. So we already have angle P as 116. And remember, we're supposed to proceed with that information. So if we found a certain angle from the previous question, be able to mark that question or that angle on our diagram so that we can be able to work with that angle for our next questions. Let's proceed. Determine the angle of M1. And remember, with M1, when we look back to our pre-question analysis, we have identified and we were told that Sn is a diameter, and we identified that this diameter, it will subtend that 90 degrees angle there. So M1 plus M2 must be equal to 90 degrees. So I'm saying M1 plus our M2, remember, is 64. It's equal to 90 degrees. These are the angles on a semicircle. Why? Because Sn is the diameter of the circle. Then M1 is going to be, we're solving for M1 there, is going to be 26 degrees. Now let's proceed. Determine given reasons, again, the size of O1. Remember, O1 is the one that we found later. And remember, we said, just wanted the value of M1. Our M1 here, remember it was, so we're going to work with that. And as you can see from our pre-question analysis also, we were able to identify that these are angle at the center. It is twice the angle at the circumference, because we can see that these two angles are subtended by the arc SR. So we are saying O2 is going to be, our O1 is going to be 2 times M1, which is 2 times 26. That is how we're going to get our O1. Then we can now say O1 is 52, which is angle at the center is twice the angle at the circumference. Now, grade 12, we have another question here. So for question 8.2, let us now deal with question 8.2. And for this question, you are given 8 minutes to complete this activity. And your 8 minutes starts now. Welcome back, grade 12. Let us discuss the solutions to this activity. Now for question 8.2, remember we can still apply our pre-question analysis here. And we are just checking what do we have when we are dealing with such a question. We are told that in a diagram ABG, triangle ABG is drawn, D and E are the midpoint of AB and AG's respectively, and AG and BG are produced to C and H respectively. F is drawn on BC such that FG is parallel to CH. So what are we dealing with? You can see that we are dealing with proportionality. So we're going to apply a lot of proportionality, because I can see it by the midpoint that I'm having and the parallel line that I am having. So what we're going to see here, we can see that these two sides are equal, these two are equal. Then we can now conclude that these two must be parallel. Why? Because it shows you that these two lines, or BDE, is going to be the midpoint of CAB and AG. So those two must be equal, and we are going to be able to apply proportionality, as you can see here. And again, I have another triangle at the bottom right there. And on the other triangle, I can see I still have parallel lines, and I'm expecting that these two sides are going to be in proportion because of those two parallel lines. So that is the part of pre-question analysis question for this activity. And when the sides are in proportion, remember, I can go the way I did, or I can just do it this way. So you must remember how we can represent proportionality. We have various and multiple ways that we can deal with proportionality. Let us look at 8.2.1. 8.2.1 reads, give a reason why DE is parallel to BH. They are saying, tell us why these two are parallel. And we could say, or we've established this already to say, we are told that AD is equals to DB, and we are told that AE is equals to FG. What do we see? We see that DE must be the midpoint as it divides the two sides equally, which is AB. Line AB is divided equally, and line AG is divided equally. So the reason is it is the midpoint theorem. DE is the midpoint of those two lines. So the two lines must be parallel. If it is further given that FC over BF, it is 1 over 4, DE is 3x minus 1, and GH is x plus 1, calculate, given reasons, the value of x. Let us now populate this information on our diagram and see how we're going to work with this activity. So we are told that FC, where is FC? Let's find the FC. So FC, it is 1. The ratio for FC is 1 over 4, which is the BF. It's 4 right there. So those are the ratios that we're having right there. And we are told that our DE, it's how much? It is 3x. It's 3x minus 1. Let's just fix that quickly. So this is 3x minus 1. We know that this was 4 and this was 1. So those are the ratios. We can attach a letter, maybe letter Y, so that we can represent it in terms of a length. Remember, a ratio we are having here, when you plot this ratio on a diagram, it must go with a variable. And it is further given that GH is x plus 1. So GH, it is what? It is x plus 1. Right. So we are saying calculate the value of x. What do we see? We see that we are already given the ratios on the triangle at the bottom here, which is BHC. We are given more information on that triangle. Let us now see, can I transfer the information I have on my triangle ABG to the triangle BHC? Let's see that. But what do we see? We remember that these two lines are parallel. What do we know that? We know that BG is going to be twice DE. That's how we're going to find our BG. So that's what we're going to say. That's the first thing we're going to do. We are going to say BG, it is twice DE. Why? Because this is our midpoint theorem. Therefore, our BG is going to be 6x multiplied by minus 2. Remember, we're going to say 2. DE, it is 3x minus 1. So into 3x minus 1, we are going to distribute the 2 as we do there. So 2 times 3, x is 6x. Then we have 2 times 1, negative 1 is negative 2. So then we are having that BG is actually 6x minus 2. And we know that GF and HC are actually parallel. So we are going to apply the proportionality here. The BG, we have it as 6x minus 2. Then when we apply our proportionality, we see that GH over BG, because those are given for us, is equals to FC all over BF. Why? Line parallel to one side of a triangle, or we can say is a proportionality theorem. And you must tell us proportionality theorem which lines are parallel, which is FG is parallel to what? It's parallel to H or CH in this case. Then what do we now have? We know that FC over BF was already given to us as 1 over 4. So there's no need to work with those variables there because we already have the variables that side. It's 1 over 4. And GH, it was how much? It was given as x plus 1. And BG, we found BG from multiplying DE times 2 by 2. Then we are saying our BG was 6x minus 2. Then we're going to solve for x here. Go to cross multiply, then our x is equals to 3. So that is the value of x in that case. Now, let us move to question 9, grade 12. Now, our question 9, we are having question 9, which is amounting to 5 marks. So we are just going to give you 5 minutes to deal with this question 9.1.